Statistics and Probability Quarter 3 Module 5. Let's talk about finding the mean and the variance of the sampling distribution of the sample mean. Let's have this example. Consider a population consisting of 1, 2, 3, 4, and 5. Suppose sample of size 2 are drawn from this population. What is the mean variance and standard deviation of the sampling distribution of a sample mean? The sample population is the consisting 1, 2, 3, 4, and 5, and we're going to draw a sample size 2 from this population. So step 1. Determine the number of possible combination of sample size 2 that you can draw from this population. So recall the formula for the combination. So capital N is the population and small n is the sample size. So capital N is 5 and sample size is 2. So let's substitute the given formula, so that is now 5 take at 2 at a time is equal to 5 factorial over 2 factorial time 5 minus 2 factorial. So 5 factorial, it means we're going to multiply the number from 5 up to 1. So that is 5 times 4 times 3 times 2 times 1. 2 factorial means 2 times 1, 5 minus 2 is 3 factorial. So that is 3 times 2 times 1. So we can cancel this 3 times 2 times 1. So what left is 5 times 4 over 2 times 1. So 5 times 4 is 20. Divided by 2 is 2 times 1 is 2. 20 divided by 2 is 10. So therefore 10 possible outcomes of sample size 2 that we can draw from this population. 2. List of possible sample and their corresponding means. So we're going to list all possible sample of size 2 that we can draw from this population and their corresponding means. First combination will be 1 2, 1 3, 1 4, 1 5. We have 2 3, 2 4, 2 5, and 3 4, 3 5, and last we have 4 5. List of possible sample and their corresponding means. So we're going to list all possible sample of size 2 that we can draw from this population and their corresponding means. First combination will be 1 2, 1 3, 1 4, 1 5, and 2 3, 2 4, 2 5, 3 4, 3 5, and last we have 4 5. Now, we're going to get the mean of each samples. So we're going to get the average of each sample. So that is 1 plus 2 divided by 2 is 1.5. 1 plus 3 divided by 2 is 2. 1 plus 4 divided by 5 is 2.5. 1 plus 5 divided by 2 is 3. 2 plus 3 divided by 2 is 2.5. 2 plus 4 divided by 2 is 3. 2.5 divided by 2 is 3.5. 3 plus 4 divided by 2 is 3.5. 3 plus 5 divided by 2 is 4. 4 plus 5 divided by 2 is 4.5. 3. Construct the sampling distribution of sample mean. So we have the data that we need in step 2. So the simple and possible outcome of sample size 2 that we draw from this population is this is the mean of each sample. Now let us construct the sampling distribution of sample means. So the first column is the sample mean. Actual, this is the value of the random variable x, which is represented by the sample mean. In the second column, we're going to find the frequency of each sample mean. In the third column, we're going to get the probability of this sample mean. The sample means are 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. Next is the frequency. Are we going to get the frequency? So the frequency is the number of times that each sample means occurs in step 2. So 1.5, it occurs only once, so that is 1. 2 is occurs once, so that is the frequency is 1. 2.5 occurs twice, so the frequency is 2. 2. 3 occurs twice, so the frequency is 2. 3.5 occurs twice, so that is 2. 4 occurs 1, so that is what the frequency is 1. And 4.5, the frequency is 1, so to find the probability of getting the sample mean is we're going to divide the frequency of each corresponding sample mean by the total number of the frequencies. So we're going to add this frequency. The total number of frequency is 10. So the probability of getting 1.5 is 1 over 10. The probability of getting 2 is 1 over 10. The probability of getting 2.5 is 2 over 10. The probability of getting 3 is 2 over 10. The, the probability of getting 3.5 is 2 over 10. The probability of 4 is 1 over 10. The probability of 4.5 is 1 over 10. Next step is to compute the mean of the sampling distribution of the sample mean. So we're going to do that. We're going to multiply the sample mean with the corresponding probability, and we're going to add the result. So that is 1.5 times 1 over 10 is 0.15. 2 times 1 over 10 is 0.2. 2.5 times 2 over 10 is 0.5. 3 times 2 over 10 is 0.6. 3.5 times 2 over 10 is 0.7. 4 times 1 over 10 is 0.4. 4.5 times 1 over 10 is 0.45. Then, last step is to add the results. So, when we add this is equal to 3. So, this is the mean of the sampling distribution of sample mean. Compute the variance of the sampling distribution of some means. Subtract the sample mean from each sample mean x. Square the difference. Multiply the result by corresponding probability. Then add the result. Next, find the variance of the sampling distribution of sample mean. Are we going to do this? So we're going to subtract the sample means from its sample mean. So remember that the mean of sample mean is equal to 3. So we're going to subtract this from each sample mean. So that is 1.5 minus is negative 1.5. 2 minus 3 is negative 1. 2.5 minus 3 is negative 0.5. 3 minus 3 is 0. 3.5 minus 3 is 0.5. 4 minus 3 is 1. 4.5 minus 3 is 1.5. Next is we're going to square the difference. So we're going to multiply this twice to itself. So that is negative 1.5 times negative 1.5 is 2.25. Negative 1 squared is 1, negative 0.5 times negative neg- 0.5 is 0.25. So, 0 squared 0 squared is 0. 0.5 squared is 0.25. 1 squared is 1. 1.5 squared is 2.25. Next is we're going to multiply this by the corresponding probability. So that is 1 over 10 times 2.25 is 0.225. 1 over 10 times 1 is 0.1. 2 over 10 times 0 is 0. 2 over 10 times 0.25 is 0.05. 1 over 10 times 1 is 0.1. 1 over 10 times 2.25 is 0.225. At the result, that is the variance of the sampling distribution of sample mean. So adding this is equal to 0.75. So the variance of the sampling distribution of sampling means is 0.75. Now to find the standard deviation, just get the square root of this and getting the square root of this, that is equal to 0.87. So that is the standard deviation of the sampling distribution of some polynomials. Properties of the sampling distribution of sample mean. The mean of sampling distribution of the sample means is equal to the population mean. The variance of the sampling distribution of the mean is given by this. The standard deviation of the sampling distribution of the sample means is given by this. So consider a population consisting 1, 2, 3, 4, and 5. Suppose sample size of 2 draw from this population. What is the mean variance in standard deviation of the sampling distribution of sample mean? So here, compute the population mean. So once again, this is finding the mean and the variance of the sampling distribution of the sample mean. Thank you and bye-bye.